Hello, today we're going to learn how to graph piecewise function manually. I like this function because this is very unique as it's not defined by a single equation like we're used to, but by two or more. Here's an example of a piecewise function which is composed in this case two functions. The first one is negative 3x plus 2. The second piece is negative x squared plus 4. Now, there's a note here. It says each equation is valid for some interval, also known as domain restriction. If you notice here, this x less than 1 is the domain restriction of the first equation, and x is greater than or equal to is the domain restriction or the interval of the second piece of the piecewise function. I'm going to teach you how to do this later. Let's go and dive into the key concept. These key concepts are the mathematical rules that we need to follow so that we can achieve our aim. I'm pretty sure that most of you are familiar with the four symbols here. The less than or equal to, greater than or equal to. Let's take a look at one of those. Now, if you see a less than symbol, according to the key concept, we need to use an open circle and keep the left side of the graph. So if you have the pull graph, let's say you have a pull line, you have to cut it somewhere based on the domain restriction and keep the left part of it. I'm going to show you the rest as we go to the next, to the model problem. Alright, now let's go to the model problem. What if we want to graph this piecewise function? I strongly suggest, guys, that you need, especially if this is your first time to graph piecewise function, what I strongly suggest is you break it down into two pieces. That's why it's piecewise function. Let's label it. So our first equation, the linear function, let's label it as equation 1, and this is equation 2 inside the triangle. Now, so we're gonna graph the first equation, and it says f of x is equal to negative 3x plus 2 with the interval or the domain restriction x is less than 1. Now notice that there is a less than symbol in the restriction, so we're gonna take one of these concepts, which is the less than symbol. We're gonna put it here because definitely we're gonna use that later. Now, how do we graph this? Since it's a linear function written in slope-intercept form, we can identify the y-intercept, b, which is positive 2, that number, the constant, and the slope, m, which is negative 3, the coefficient of x. But we have to write it as a fraction because, as you all know, when we graph a linear function or a line, we need, as the slope is rise over run. So it's negative 3 over positive 1. This is our rise over, that is our run. Now let's graph. So to graph this line, we need to start from the y-intercept, which is positive 2. If I'm at the origin, I go up 2 steps, 1, 2. And then I strongly suggest, guys, that when you're graphing, you use open circle for now. But once you get the hang of it, you know what to do later on. Now, from here, we are going to apply the slope. It says negative 3, meaning you go down 3 steps and then 1 to the right. So from here, from the y-intercept, 1, 2, 3 down, 1 to the right. Again, you're gonna use an open circle for now. Repeat the process. Negative 3, 1, 2, 3, down, and then 1 to the right. And of course, if you want points on the upper part of the grid, you need to reverse the sign. So instead of going down 3, you go up 3 from the y-intercept 1, 2, 3, 1 to the left. Again, an open circle, going up 1, 2, 3, 1 to the left. Now, imagine if I'm going to connect all these open circles or the points, we are going to create a line. But are we going to draw the entire line or the line graph? No, because of this interval or the domain restriction, it says less than, x is less than 1, less than positive 1. Where is that positive 1? Positive 1 on the x is right here. So we're gonna keep, it says here, if you have a less than symbol, you need an open circle. That's why we have an open circle here. Then keep the left part of the graph. So imagine there's a line from here, from that point, that open circle, you need to keep the left part. This is the right part from here down. So how do we do that? Just simply connect all the points, the open circles from here. Make sure you don't hit the open circle there, and then draw the arrowhead, write down 1 just to indicate that your first equation there, or first part, first piece. So what happened to this circle, this open circle? Is it part of the graph? No. So since you're using a pencil, you need to use a pencil. Just erase it. That's how we erase it. Please subscribe.